My name's Jonathan Hicks. We're doing angle problems. Now you need to have watched the angle facts video for this to make any sense really. I'm using all the facts that we learnt about in that video to solve various problems in this video. What you might want to do is, after I've explained what the problem is, you could pause the video, try and solve it yourself, and then you can hit play and see if you've got the right answer. So we'll launch in with our first problem. Imagine you've got two straight lines that cross like that. We're going to be told that this angle here is 50 degrees, and we need to work out what that angle is and that angle. So X and Y, these two angles, we've got to find out what they are. Okay, so first things first, this 50 plus the X, you'll notice they sit on a straight line. There's a straight line that goes along there, which means that those two must add up to 180 degrees. Angles on a straight line always add up to 180 degrees, which means that X is going to be 180 degrees minus 50. That will give us our answer. In this case, obviously 180 minus 50 is going to give us 130 degrees. Secondly then, Y. Now there's two ways you can look at Y. First of all, probably the easiest way, it's opposite the 50. Yeah, you've got one straight line there, another straight line here, they're crossing, so you've got vertically opposite angles here, which means Y must be the same as 50, so Y is 50 degrees. The other way you could look at it is, knowing that X is 130 degrees, you've got a straight line that sort of comes down there, so X plus Y must equal 180, so 180 minus 130 gives you 50. But as you can see, just spotting that it's opposite the 50 will be the easiest way to do that one. Okay? So that's our first problem. Now I'm going to make these get progressively harder as we do them. So see how you do here. Alright, next one, we're going to have a straight line across there. Another line is going to go straight up, and we're going to have a 90-degree angle there, a right angle at that point there. And then we're going to have another straight line which crosses at that point. So that's one complete straight line. And then there's another line that just sticks out like that. I'm going to give you a few angles here. This angle here is going to be 25 degrees, and this angle here is 40 degrees. We have to find out the other three angles, so we want to know what this angle is. We'll call it A, this one B, and C. So there's the problem. Pause if you want to have a go. Alright, here's the solution. So, first of all, you must realise that we know what this angle is. Yeah, that's a 90-degree angle. So, we can work out A, again because it sits on a straight line. You've got a straight line all the way along there. So the 90 plus the 25 plus our unknown angle A have got to add up to 180. So again, A is going to be 180 degrees minus the 25 minus the 90. So let me do that underneath now. So 125, well, minus the 90 is just going to give you 90. Take away another 25, and you're going to get 65. So A has to be, I'm going to sneeze. Nope, it's gone. A is going to be 65 degrees. Alright, so now B or C. Well, I would use this straight line next, and we can do a very similar thing. Sometimes it's quite hard to see those straight lines when they're there, but if I sort of cover up that bit there, you can see there's a straight line there. So A plus 40 plus B again has to add up to 180 degrees. So B is going to be 180 again, those three, minus the 40, minus whatever A was, and A was 65 degrees. So B therefore, well, 180 degrees minus 40 is going to give you 140 degrees. Take away 65, and I think you'll get 75 degrees. So B, we've now figured out as well, is 75. So that was A, that was B. Now C, well, now that we know all the angles around here, the whole lot's got to add up to 360. So you could do 360 minus 90 minus 25 minus 65 for A, minus 40 minus 75 for B, and that will give you C. That's probably a little bit of a long way around, but you could do that. Another way of doing this though would be to say you've got a straight line along here, so these three angles again will add up to 180 degrees. So a lot of this is just about finding where the straight lines are. Again, you've got another one there. Those three will also add up to 180 degrees. So either way around, I'll perhaps use the one on that side. So we'll do 180 degrees this time, minus the 25, minus the 90, and that should give us this one here, because that's the last one in the set. So 180 minus 90 again is going to be 90 degrees, minus 25, it's actually exactly the same as that one. C is going to be 65 degrees. And in fact, if you're astute, you may have noticed a quicker way of doing this, because you've got a straight line there and along there, those two straight lines cross, these two angles are vertically opposite. So actually, once we knew A, we could immediately find out C. We didn't even need to do that calculation. You'll find a lot of time with these angle problems, there's often a quicker way. There's a sort of long way around and then a quicker way. And if you can spot the quicker way, it's great on an exam because it saves you time. That's the main thing you want to benefit from here, is the faster you can get there, the more time you can spend on those difficult questions that often appear at the end of the paper. All right, let's make it slightly harder. We're going to introduce some parallel lines now. Now, if you remember, there was a few rules to do with parallel lines, and you do need to remember them. Even if you can't remember the names, so this is the corresponding alternate interior, you need to just remember the facts. If you know what the facts are, you'll be able to work out the angles without too much trouble. So let's say we have a pair of parallel lines like this. So again, we stick the arrows on here to indicate that they're parallel. We're going to have another line crossing like this. I'm going to tell you that this angle is 115 degrees, and we want to find this one. So again, there's a couple of different ways you could do this. In order to find out what this is, we need to find out one of the ones that sort of matches around here. Now, there's no shape. If you remember, I had F shapes and Z shapes and C shapes and things. You need something that will connect the 115 with the X, and none of those shapes are going to do it directly. What we could do though is we could connect the 115 with this angle here. Again, you've got a straight line. Those two angles will add up to 180. So we can work out what this angle is. So in this case, 180 degrees minus 115 is going to give you 65. So that has to be 65 degrees. Now I can see one of my shapes. If you can spot it, I can see a Z shape. So along there, down here, and along there. With the Z, those are the parallel bits, and the two angles that sit inside the crooks of the arms of the Z, those two angles are called alternate, and they're always the same. So here, X would have to be 65 degrees because it's alternate. Sometimes in some tests they will ask you to give you reasons, okay? So if they're asking you those kinds of things, you will need to learn these words. But otherwise, you just have to figure out what the angle is. In this case, you can see it's 65. Now, another way you could have done this, you could have used 115 to work out what this angle is here. Now again, sitting on a straight line, these two have to add up to 180. So again, that's going to be 65. 65 plus 115 gives you 180. And now I can use a different shape to get me from here to here. So let's say I hadn't worked out what this one was, but hopefully you can see there's a kind of upside down F shape. Maybe if I just draw over that so you can see that a bit clearer. Yeah, so there's a kind of upside down F shape. And these two angles would be the same. These are said to be corresponding. So in this case, you could say, again, those have to be the same. Corresponding angles are always equal. So X would have to be 65 degrees. This time, though, your reason is it's going to be corresponding to this one. So it could be alternate to that one or corresponding to that one. Corresponding. Okay, so that was a fairly simple problem with parallel lines. These do get harder though. So let's draw one with some triangles. They often love combining these parallel line questions with triangles. So we're going to have we're going to have a straight line that goes straight down like that to start with. Then I'm going to have a line that comes across to there, and then down to here, and across to there. Now these are going to be right angled triangles, both of them, and those two diagonal lines on the triangles are going to be parallel. That one is parallel to that one. I'm going to tell you that this one is 60 degrees, and we have to find that one. Alright, there's the problem. Pause if you want to have a go. And here's one way you could work this out. Now first of all, we're going to need these parallel lines to connect the angles here into here. But I think it's going to be easiest to try and connect this angle from the parallel lines into here rather than trying to do that one. So I'm actually going to use angles in a triangle first of all. Yeah, all the angles in a triangle have to add up to 180 degrees. So this one is going to be 180 minus the 60 minus the 90 because it's a right angle triangle. So in that case you're going to get 30, I think, when you do the subtraction, which means that this angle at the top here has got to be 30 degrees. Now I know what that one is, I can try and connect it to this one, and this is where I need to use my parallel lines facts. And the one I'm going to use here is the corresponding fact. So we've kind of got this situation, it's like a backwards F shape this time, which means that those two angles that sit underneath the bars of the F will be corresponding, so they'll be equal. Those two angles must be the same, so X here has to be 30 degrees. So that's fairly straightforward. Now, as I say, if sometimes when they ask you these questions, they'll ask you to justify your answers. So this one equals 30 degrees, and that's because angles in a triangle add up to 180 degrees. That would be your justification for that one. And then this being 30, you can just say it's corresponding. So you wouldn't need to write much more than that. When they ask you to justify your facts, they only want a little bit. But you just have to make it clear what rule, what angle fact you've used in order to work it out. So to work out the 30, we use the fact that angles in a triangle add up to 180 degrees. To work out this from that one then, we use the fact that it's corresponding. So that will be enough, but that's the kind of justification they want if they ask for it. As I say, sometimes they do, sometimes they don't, sometimes they'll just give you the problem and they'll say, find that angle. And you can do it any way you like, and you don't need to explain how you got there. All right, last one then. Make this a little bit harder now. So we'll have two parallel lines there and there. So those two are parallel. And I'm going to sort of make a triangle in the middle here. Something like that. And if we label these perhaps, so we'll say that point there, that corner of the triangle is P, the top corner here is going to be Q, and the bottom corner there is going to be R. Okay, and what they're going to tell you first of all is that PQ, the length PQ there, equals QR. So that length and that length are the same. We could put a little line, a dash across those to indicate that those two are the same length. But they're telling you that in the question. And then finally, they're going to give you this angle here. You're told that that's 50 degrees, and we have to work out that angle there. So pause if you want to have a go. Here's the solution. Now at first you might think, oh, I've got a straight line here, great, so that plus that plus that adds up to 180. Oh, but we don't know what that one is. Now it looks like it's the same as that one. And it might be the same as that one, but you don't know. You can't just assume because it looks the same that it is the same. You need to use some kind of angle fact in order to establish what the angles are. And these, you have to be quite careful. Sometimes they'll design these questions so it looks like they're the same, but actually they're not. And sometimes they will be the same, so you've got to be very careful. That's the main thing. We need some kind of angle fact. I'd quite like to use the fact that I've got a triangle here, angles in a triangle I know about, so maybe I can use this one to figure out what one of these angles in the triangle is. Because I've got the parallel lines, I can, because this one and this one will sit inside a Z shape. So this one is the first one I want to try and figure out. And hopefully you can see that Z shape there means this will be 50 degrees. They've got to be the same. So that's the first thing I was able to do. I was able to work out that that's 50 degrees because they're alternate angles. Next up then, this one, I think I can figure it out. Because PQ equals QR, there's a reason why they've told you this. It's a bit of information you need to use somehow. Those two sides are the same, and that's a special kind of triangle. When two sides are the same, it's called an isosceles triangle. And if those two sides are the same, if it's an isosceles triangle, then the bottom two angles must be the same as well. So immediately, I know that that angle must be 50 degrees as well. Now, I've got the 2 out of the 3 angles in the triangle, so I can use angles in the triangle to work out the one I really want, which is x. So in this case, x is going to be 180 degrees minus the 50 minus another 50. So effectively we're just taking away 100, which means that x needs to be 80 degrees. I won't write out all the justification for this, but if you had to justify it, there's 3 steps here. So firstly, that's 50 degrees because it's alternate to that one. That's 50 degrees because angles in an isosceles triangle, those two are always the same. And finally, this is 80 degrees because angles in any kind of triangle always add up to 180. So that's about as hard as it gets, but you do often need to use different facts, and they'll combine things like triangle facts, parallel line facts, angles on a straight line add up to 180 degrees. You need to sort of pick from your various tools the different facts and options you have available to decide how best to solve the problem.